Today is day 7 of Unit 5. We're going to be learning about graphing square root functions. Before we do that, remember yesterday's lesson was step functions, which is pretty much a type of piecewise function. So you have a couple different functions. For step functions, you have pieces of horizontal functions, and what you should notice is, number one, it's called a function. So remember, a function cannot have two x coordinates over top of each other. But remember, if it's an open dot, that actually means that that point is not included. Okay. The purpose of having the dots, though, is, remember, between the numbers -2 and 1, there's not just integers, so -2, -1, 0, 1. There's also decimals, fractions, all those other rational numbers that come between those two intervals. Okay, so again, just like we did in piecewise functions, we take this function g of x and we break it up into the different steps. So again, -1, y is equal to -1, that would be just a horizontal line that goes through -1. But we only want it from -2 to 1. All of your points that are furthest to the left, so remember our intervals are always least to greatest, so the one that's on the left, those should all be closed dots, whereas the ones on the right should all be open. Okay, and again, a step is just showing you that, you know, if we're thinking about our range, so as I'm going, so when x is -1, -2, -3, -4, so x, I meant to say y, sorry, when y is -1, y is -2, y is -3, etc. That means that when it's between -1 and -2, so like -1.5, the function does not exist, okay, because it actually steps down each time. So the range is literally -1, -2, -3, -4. Can't be anything else besides that. For question number 5, that one was a little bit trickier, but I think once we go over it, it will make sense. The first thing that you want to do, because they gave it to you, is they told you that the number of people is x and the number of tables is y. So before you even do anything, you should label x and y, label the number of people, and then label the number of tables before you even know what numbers to put on each line. Okay? The next thing is to read. So each table can hold 10 people. So what I did was I went by tens. I recommend doing that. If you started at 1, your step function, you wouldn't have a step function. You'd only have the first step. Okay, so then I did 1 through 10 on my number of tables. They didn't tell you how big to make it, but again, if this was a Regent question, just go all the way up to the end till you can't go anymore. Okay, so the next thing I want you to think about is, so if you had 0 people at a table, you'd need 0 tables, okay? So if you wanted to put a dot there, you could, but it's not necessary. So then, remember, it maximum holds 10 people. So can one table have 1, 2, 3, 4, 5, 6, all the way up to 10? Yes. So that's where our step function comes into play. Once I get to the number 11, now I jump up. So remember, the reason why we put this open dot is because, well, 10 is not included, but between 10 and 20, there's all those numbers. So we need to draw the line to signify 11, 12, all the way through 19, and then our dot is over to 20. Now once I go to 21, now I got to hop up. So open dot, and that goes all the way up to the top. All right, so moving on to today's lesson, again, we're going to be talking about how do we graph square root functions. Okay, that's our goal for the day. So the first thing, and if you do not have your graphing calculator out, please grab one just so we can go over how to put that in your calculator. So if we are trying to figure out what a square root graph looks like, the first thing we should look at is what would the function look like. So for the parent function, which just means the most simple, okay, the simplest function of that. So if you think of your parents, where you came from, right, where you originated from. So all square root functions originate from y is equal to the square root of x. So the parent function of a linear equation is y equals x. The parent function of an absolute value is y equals the absolute value of x, and so on and so forth. So basically there's no transformations. There's no shifting left, right. There's no stretching, getting narrower or wider, anything like that. Up, down, etc. Okay, so the next thing I want to do is I want to sketch this. So if you go into your y equals, okay, if you hit your second function button and then go to your x squared, right above it is square root. Okay, and then you're going to type in an x and then press graph. Okay, now your sketch, if it ever says sketch, we don't need points. So we know it's going to be starting at 0, 0, and then it's kind of going like this. Okay, again, I just want you to have a little sketch going. Okay, and we'll talk about that in a minute. The next thing, let's talk about the domain and range. Remember, the domain is, and we can do this, sketch. Okay, our domain is the x values, and the range is our y values. Okay, so when you take the square root of a number, okay, there is no possible way that you can get a negative, right? Similarly, there's no negative number you could square root that will get you a negative, okay? So, what I mean by that, if I go to my table, all right, notice that when my x is negative, it's an error, okay? It's impossible. Similarly, for the y's, it stops at 0. It's never going to be negative. Okay, so for both of these, domain and range, now 0, 0 is a coordinate, so it can be 0. Okay, the square root of 0 is 0. So x is greater than or equal to 0, and y is greater than or equal to 0. And then a description, a smooth curve extending infinitely in only one direction. So now just a couple facts. So we want to answer the question, why does it go only one direction? Well, we can only take the square root of non-negative numbers. Okay, remember, a square root is the opposite of squaring something. Well, if you square a positive number, you're going to get a positive. If you square a negative number, it's going to be still a positive. So if I'm going backwards, if the product of, I won't say product, that sounds like multiplication, but if the answer, the solution of squaring something can never be positive, that means that you can never take the square root of a negative number and get an answer. That's impossible. Because remember, a square is two of the same thing. Well, the only way to get a negative answer would be a negative times positive, or a negative divided by positive. So make sure that the radicand is greater than or equal to 0. Okay? And the radicand is the number, let me type this up. So the radicand is the number under the radical, and a radical is just the square root symbol. Okay? So now what we want to do is we want to describe the possible domain or x values for the functions y is equal to the square root of x minus 3. So what we do, which is pretty nice and simple, is we take the radicand, all right, and we set it greater than or equal to 0, and then this actually gives us the range without much work. So I'm going to do plus 3. Okay, so you're just solving an inequality. So this is my domain for number 1. Okay, similarly for number 2, again, this doesn't matter. Okay, all we want is that. So we set 3x plus 9 greater than or equal to 0. So I'm going to subtract 9. So x is greater than or equal to negative 3. Okay. And that's how you would find the domain, or your possible x values for a square root function. All right, so now we are going to graph these functions in our calculator. So I'm actually just going to leave that in there. So I have the square root of x. Now remember, when you have something underneath the square root in the TI 83 or 84, if you're in the parentheses, you're still under the square root symbol. So I want to do the square root of x and then go outside the parenthesis plus 2, and then I will look at my graph. Okay, so now this is square root, so not all of your numbers are going to be whole numbers. So the other thing you need to think of is what numbers are going to help me most by plotting on my graph. So this says to graph, not to sketch, so it needs to be precise. So I'm just going to use, let's see, 0, 1, so let's see, 0 goes to 2, 1 is 3, I'll use 4, and just to get a nice curve, okay, I'll do 9 goes to 5. Okay, so then again, you are just going to plot that on your graph. So that's what your graph should look like. Okay, again, I just plotted those coordinates and then draw a nice smooth curve. The next thing, we want to describe how this graph compares to the parent function. So if you look back to our sketch, all that's happening is this shifts down. Oh, sorry, up. Okay, sorry about that. So shifts up 2 units. Okay, remember, if it's on the outside, it goes up or down. If it's on the inside, it goes left or right. Okay, and then we're going to state the domain. So again, it cannot go, okay, can't go any further to the left. So x must be greater than or equal to 0. Remember, domain is our x values. Okay, now we are going to graph the next function. So this is all under the square root. So again, go ahead and hit second function, x squared. That will give you your square root. Do negative 2x plus 6. Notice that's all in my parentheses. If you have a calculator that draws the square root symbol, just make sure that it's all underneath. Okay? End your parentheses and go ahead and graph. So you can get the kind of general idea. Okay, but remember, we want some specific numbers. So what I did for this one is I noticed that I'm going to have to do some negatives. So I'm going to start with, let's see, I'll start with negative 5. So negative 5, 4. Nah, that'll probably be our only negative. Okay, so negative 5, 4, and then go back towards the positives. So 1, 2, and 3, 0. Once we hit 3, 0, then we cannot go any further. Okay, so you're going to go ahead and graph these like I've done so. Okay, and then the last thing we're going to do is our domain and range. Okay, so x and y. All right. Again, for your domain and range, these are always going to be inequalities. Okay, so I see that my domain starts at 3. Okay, and then it goes to the right. So x is less than or equal to 3. That will be my answer for that. My range, I see that it starts at 0 and goes up. Okay, so y is greater than or equal to 0. All right, so the rest of the examples for this day 7, so graphing square root functions, 5 through 7, I'm going to give you for homework. I just wanted to point out, okay, so homework numbers 5 through 7. Remember, please do this during class if you do not understand, so we can go over it. Okay, so the only thing I wanted to show you for number 5, it's a multiple choice question. I just wanted to kind of break down the, this is called set builder notation. Okay, you can really disregard the x. All it means is it's basically describing the domain. So x exists when x is blank. Okay, so the function exists when x is blank. All right, I want you to try that for homework. Again, remember that you can use a graph. I showed you how to do this algebraically as well with questions number 1 and 2. Okay, or you can just use numbers 3 through 4 and 3 and 4 and use how I found the domain and range.